Ready?
Okay. So we want to find Cartesian form of this vector towards F, part A, right? Fx, Fy, Fz, ijk components. So in order to do that, first I need to project this force into the xy plane. You see? Now look at this triangle. Look at this triangle. First I need to find this guy, the length of his base, right? And then I go ahead and project it into y and x. So that's going to be Fy, right? This is going to be Fx, and this z component is Fc. See that? So in order to, this is a 3D vector, it's not in whiteboard, this is like outward, right? So in order to find the three components, you have to do two steps. You have to project into xy, and then the second step, you project this xy into x and y. The z component, however, is just very straight. Now, let's call this base f prime from here to here. You see that? Let's call f prime. So what's the value of f prime?
600.
Thank you. 600 cosine 60. Why cosine 60? Because this angle is between this one and the force. This angle is sharing. This side is sharing the angle with the force, so it's co. The other one is sine. So if this is 600 cosine 60, the other one is what? Fz is what?
Sine.
600 sine 60 degree. Right? Am I done?
Nope.
No. I need to do the step number 2. So this is in xy. I need to go ahead and find the y and the x component. So what should I write for Fy? If this angle is 30, what would be this component? See, this component is sharing the angle with this value f prime. So the value of Fy is going to be f prime times f prime times cosine 30. And since f prime is already 600 cosine 60, so that's going to be 600 cosine 60 for f prime, right? Times cosine 30. And you can see it's positive, right? Now let's go to this component, fx. So fx is what? F prime times f prime times.
Sorry, what?
Fx is f prime times sine 30. Thank you. And f prime is 600 cosine 60 times sine 30. So you see this long expression, some sine and cosine, come from the fact that this guy is already 600 cosine 60. Right? Now you have FC. Now, am I done? Am I done? Yeah. Everything fx, y, z. All I need is just to plug it right here, right? So what should I put here? Then this is the time you ask for direction. Is it positive or negative? Because look, with only this at hand, with no graphical picture, we can't say which one the vector is what direction, right? We have to say positive or negative, right? So here is positive or negative? Negative. Prime. And the value is, the x component is?
600 cosine.
600 cosine 60 times?
Sine 60.
Sine 60. Sine
30.
30. Alright? This guy, you see? 600 cosine 60 times sine 30, and it's negative. Look at the arrow is going to the negative direction, right? What about Fy? Fy is this. Is it positive or negative? Positive 600 cosine 60 times cosine 30, right? And Fc is just simply 600 sine 60. All right, so this is the first part, part A, right? You can go ahead and simplify, put in the calculator. So Fx, let's put in the calculator. So I'm going to load my calculator. It's going a little bit slow, so 600 times cosine 60 and it's going to be negative 155 plus 259, almost 300 J. I'm sorry, 159, 260 J, and then the K component is 600 times sine 60. Plus 5 times JK. Now, this is my force, okay? Part B is asking for the direction, the angle between this direction, the force direction, and this pipe segment from O to A. So if you can imagine in three-dimensional space, this is the pipe and this is the force, right? There is a three-dimensional angle like that between them, right? You need to find that three-dimensional angle. So what should I do? Well, we need position vector, right? How? Yeah. Yeah. So as he said, we need to find position vector. How do I find position vector? We use coordinate vector. So coordinate vector O is given 0, 0, 0. Coordinate vector A is also given. Now you use this measurement, right? And then you find the position vector, and then you do what? Let's say you have this vector and these two vectors. How do you find the angle between two vectors? Dot product. It was the first application of the dot product. Part C, it asks you the second application of the dot product, which is the projection, right? So let's find OA, the position vector from O to A, which is simply RA minus RO, right? The end minus the beginning. And the beginning, it turned out to be 0, 0, 0, right? 0I, 0J, 0K. So a vector minus 0 is itself, right? So it's simply RA. So what's the RA from the figure? It has 4 feet in the negative x, so it's negative 4I plus 4 in the j plus 2 in the k, right? So look, my position vector is equal to negative 4I plus 4j plus 2k. So this is one of the vector, and the other one is this, the force vector, right? The other one is this guy. Now the question is, what's the angle between these two vectors? Well, you can simply write first vector dot the second vector is equal to magnitude of the first one times the magnitude of the second one times cosine the angle between them. Let's say the angle between them is theta, right? And theta is the angle in 3D space, is the angle between this direction and the force, so it's this angle. See that? That's the theta. Now, all I need is just this value, right? So if F is this, what's the magnitude of F? Magnitude of F is the square root of 150 square plus the second component 260 square plus 520 square, which is equal to, we grab the calculator, square root of 150 plus 260 square plus 520 square. It's 600 point, just 600 on something, right? Now, what else do I need? The magnitude of RA. Magnitude of RA is equal to square root of 4 square plus 4 plus 2 square, which is equal to
6.
16, 32 plus 4, 36. Square root of 36 is 6, right? So what else do I need? I have this guy. Thank you. I have this guy. I have this guy. I need to do dot product. And this result, the result of dot product of two vectors is what? A number. Is a scalar. And then you end up with the cosine is a number divided by a number. And then you do arc cosine and find the angle. This part E, the bonus part, right? So here, F dot RA is equal to, you have negative 150 I plus 360 J plus 520 K dot with RA. RA is negative 4I plus 4J plus 2K. Right? Plus 2K. Now, this becomes negative 150 times negative 4 plus 260 times 4 plus 520 times 2. Put it in the calculator. That's going to be 2,680. Well, let's just put in the formula. Now I go back to the formulas, right? Then the dot product is 2680 is equal to magnitude of A, F 600 times, magnitude of RA 6 times, cosine theta. That means cosine theta is equal to 27 divided by 2 then you do arc, so it's going to be 0.74, right? And then you do and then you do arc cosine, this calculator is second. Arc cosine 0.7. So that's 41.9. Theta is 41.9 degrees. So that's the answer to part B. Now, in part C, what we need to do, we need to find, we need to find parallel and normal, F normal and F parallel. How do you find the parallel and normal component? The concept of projection. Well, as we discussed before, you need to have a unit vector in this direction. Now the dot product gives you the parallel component. The vector minus the parallel is the normal. So let's find unit vector in the direction O to A. So the unit vector, I write it here. This is part B. Now I want to do part C. So I need to have unit vector from O to A. So how can I create this unit vector? Thank you. The vector divided by its magnitude. So we go, the vector I have, R8 in that direction, divided by magnitude of RA. Right? So that's going to be negative 4I plus 4J plus 2K divided by its magnitude. We already computed here, right? So that's the advantage of saving your data, because you can reuse them instead of just computing again. Divided by 6, right? So you can either further simplify this divided by 2, negative 2, 3I plus 2, 3J plus 1/3 K. Now that's your unit vector. Now, what is, let's write it here. What is my parallel component? A projection. What's my projection? You say F, right, parallel with this symbol for the projection is simply F dot U. This is just the magnitude of projection dot product, right? We should multiply by unit vector to get the vector in that direction. So that's it. So we do, which one is F? F is 150 I plus 260 J 120 K. Right? So this one, let's put it here. Let's first do this guy. F dot U, right? That's 150 I plus 260 J plus 520 K dot U. And U is negative 2 over 3 I plus negative 2 over 3 J plus 1 over 3 J. Simply this dot product. And then this is just so easy. This time this, plus this time this, plus this time this. The end result is just a number, right? So what I'm going to do is just immediate calculator. So negative 150 times negative 2 over 3 plus 260 times 2 over 3 plus 520 times 1/3. So I get 4, 4, 6. 3 significant digits for 4, 7. Right, that's what I get. So this guy is 4, 4, 7. Right? So F parallel is not a number, it's a vector, right? You see this head? This arrow here? So this number, I should put it here and multiply by unit vector. So what I get at the end is 4, 4, 7 is magnitude times unit vector. And unit vector is negative 2 over 3 I plus 2 over 3 j plus 1 over 3 k. And that becomes finally 2 times negative 298 plus 298j, and then finally 7 plus 149 8. This is the answer. This is F parallel. Look, the parallel component is a vector itself. It's not just a number. The magnitude is just a number. The magnitude, the side, is just a number, which is this. The magnitude of this vector is this. But itself, you see, it has ijk, so it's a vector, a parallel. What about F normal? Now this is the last part of part C. What about F normal? How can I find F normal? So let's say I have F and F parallel, the numerical value. What's the value for F normal? Thank you. F normal is just the simplest thing ever. You just come here and you write F normal, you see with this sign, the normal sign, is equal to F minus F parallel. You showed that before using vector, just vector addition, right? So just plug the numbers here. F is negative 150, I plus 260, J plus 520, K minus F parallel. F parallel is negative 298, I plus 298, J plus 149, K. All right? The final result is equal to 298 minus 150 I, which is 148. 260 minus 298 negative 38 J and 520 minus 149 plus 371 K. So that's your F normal. F normal, you see this normal angle. So in fact, this original force can be decomposed into two components, the normal component and parallel component. To what direction? The direction along the pipe. You see this is pipe. You always have a parallel and a normal component in 3D space. You can see the vector on the 3D space. So this answer to part C. And the angle is 41.9, part B. And the vector is this guy, part A. So answer to A, answer to C, answer to C, and this is answer to B. All right.